All right, moving on to Unit 4, Section 6, and after this, you should be able to solve problems involving the order of operations with rational numbers, including exponents and radicals. So it's an extension of Unit 4, Section 5, but first, a review in exponents, and we're going to extend it to 15 this time. So we have n equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we're adding 14 and 15. Okay, so this will be n if we were to square it. All right, so we have 1, 4, 9, 16, 25, 64, 49, wait, not 64, should have called me on that one, 36, 49, 64, 81, 100, 121, 144, 169, 225, whoa, you can't see, 225, and then 14, I gotta look up, 14 squared is 196, 190, oh, that's easy to remember, 169 and 196, 169 and 196, all right, for our squares, okay, and then for our n cubed, 1, 8, 27, 64, 125, 216, then it's 343, 512, 729, and 1,000. Okay, I'm gonna do that for some time. Just repeat. Okay, and then the square root is the reverse. All right, so here, going off of PEMDAS. Please excuse my dear Aunt Sally. All right, so parentheses. We gotta work the thing here in parentheses. So 1/2 of 4. Okay, we're gonna work this one first. 1/2 of 4 is 2. So we have 2 to the -3, and we still have -3/4 of 12. Remember, of is multiplication in mathematics. Okay, so we can do that one as well. Let's break that one. Let's change this side to purple. Let's do this to purple. -3/4 of 12. So this is negative. So this whole thing is going to be negative. Okay, not to be confused with that negative exponent. Negative exponents make things go on the bottom side of the fraction, which this whole thing is over a fraction of 1. Okay, and it was -3/4 of 12. -3/4 of 12 is, well, if we broke 12 into fourths, each fourth would be how much? Think about that. 3. We got 3, 6, 9, and then 12. So 3 of those is 9. So 9/12 is 3/4 of 12. 9/12. And if you're going to reduce 9/12, it's going to 9/12 or 9/12. That's not right. 9/12. So 3 times 12 is 36 divided by 4. So another way to look at that is 3 times 12 is 36 divided by 4. Okay, what's 36 divided by 4? That's going to be 9. Okay, so it's going to be, so our answer is going to be 36 divided by 4. Let's look at that. 2 to the -3rd times -9. Well, let's still outside parentheses. Or we could just write it like this, I suppose. Okay, so that's what we're dealing with now. All right, so what happens to that? What happens to this -3 applied to that 2? Well, it's going to send it to the bottom of the fraction. So now we have this negative sign goes out front, and we'll have a neutral fraction bar, and then we have 2 to the 3rd over 9. Okay, well, what's 2 to the 3rd? This negative sign is applied to the whole. Actually, let me do it like this. Little steps. So it's -9 over 2 to the 3rd. Getting a little out of focus. Okay, -9 to 2 to the 3rd. Okay, so now I just got to make this negative. This is a negative over a positive, so the whole thing becomes negative. And it's 9, it stays 9, and then 2 to the 3rd is, well, 2 times 2 is 8. So this is 2 times, this becomes 2 times 2 times 2, which is 4, which is 8. So this is -9/8, so we're 1 1/8 negative. I'm good with -9/8. Or if you like -1 1/8, that's good too. Okay, so that's how you do that one. Let's move on to this one here. Okay, PEMDAS. Okay, excuse my dear Aunt Sally. Parentheses. We have this 1/8 in parentheses, and it's raised to the -1. Right? That means everything inside of this is raised to the -1, or you just invert the fraction. All right, that's really the best way to do that. When you invert this fraction, it becomes 8. Okay, but that's all by itself. It's separate. This is a term separated by a plus sign, so you can just kind of treat it by itself. Okay, this 5 squared is an exponent. Right, becomes before multiplication, so you can treat it by itself because it's before multiplication. So the 3 is going to be multiplied after I square it, so I can go ahead and square that, make it 25 times 3. Okay, and then my exponent happens way before I subtract, so I'm going to have to. An exponent, remember, this is an exponent. A radical bar is an exponent. Technically, this is -125 to the 1/3, right? Technically, right? And what do I have to do? -125. I got to break this into something multiplied by itself 3 times to get -125, right? So okay, maybe let's do 125 and see if we can figure something out. Okay, let's try with 25. It's 25 times 25 is 125. Okay, well, that doesn't work. What if I do times 25? What if I do 5 times 5 times 5? Okay, well, that's okay, that works. Except it's negative, because 5 times 5 is 25, times 5 is 125. All right, but if I make these negative, all right, so -5 times -5 times -5 is -125. So the cubed root of -125 is -5. So this is going to be -5 minus. Okay, so now I look at everything. Now I'm looking at my negative signs. All right, so I got my parentheses done. I got my exponents done. All right, now I got to look at my multiplication. My multiplication is right here. Okay, now I have 3 times 25, which is 75. Okay, I have my negative sign right there. Technically, I guess technically, if you want to be technical about it, it's -3 times 25. All right, so it's negative 75. Okay. Now I have negative 5. Now, so I'm done with my multiplication. Done with my multiplication. I don't have any division. Okay, now I have adding and subtracting. Okay, so I'm going to combine my terms together. So I have negative 5. I'm going to adding and subtracting. I'm going to add and subtract. I have negative 5 minus 75 plus 8. Okay, and I can do this really in any order. Okay, so if I add 75 and 5, I'm going to get 80. Or if I subtract, if I take 75 minus 5, or 5 minus 75, I'm going to get negative 80, right, plus 8, I'm going to get negative 72. Right, check it with the calculator. 5 negative minus 75 plus 8, negative 72. Okay, moving on to this one. All right, they gave us a crazy thing with some variable components in here. Not a big deal. I just replace the variable components with what it tells me the variable is. I just do some substitution. All right, so I'll do that first. So this is 2 times, so first I'll show you, this is 2/3. This is 2/3 times the radical 21 times 2/3 plus 6 squared minus 1. So I did my substitution. Okay, don't forget about the parentheses. Now if I have this, right, this whole thing right here is being multiplied by the 2 in 2/3. Right, this is part of the numerator of 2/3. I'm going to rewrite that to show that. So this is 2 over the square root of, let me make this bigger, over 21 times 2 over 3. Okay, why did I do that? Right, because this 2 is part of the numerator of 21 times over 3. Okay, this is this 21z, where z is 20, or is 2/3, is written as, it's going to be 21 times 2/3, and this is 21 over 1. Okay, so this is going to be equal to 21 times 2 over 3. Right, so this is 21 times 2 over 3. Okay, the 21 goes in the numerator with the 2. Okay, so and then we're just going to do plus 6 squared minus 1, and this is all over that 3 on the bottom. All right, so this is the mess that we found ourselves in now, but now it's not too bad to clean it up. Okay, this is still in parentheses. We got to follow PEMDAS. Right, parentheses. Work the parentheses first. We're going to work this parentheses first. Okay, so our parentheses is 6 squared minus 1. It's going to be 36 minus 1, so we're going to have 35. Okay, and it's positive. Now we're going to work inside this radical. We're working inside the radical, okay, because we're working the exponent in PEMDAS, so we're working inside the exponent. Work inside out, okay, when you're working these things. We're working the inside of the inside first, okay, we're done with that. Okay, now we're working this fraction inside the radical. Okay, we're working inside out. So we got 21 times 2 is 23. Divided by 3 is 23/3. So 23/3. 23 thirds plus 35. That's going to be the square root of the sum of 23 thirds plus 35 times 2 over 3. Fuck is that? 14. Well, that's a times.